Hello friends, myself Dr. Namdev Matne, Department of Chemistry, Sate College. Today I am going to preparing a Moodle about TYBSc Semester 5 Analytical Chemistry Paper 4 according to Mumbai University syllabus. In this paper 4, today we are going to discussing the unit 3 that includes optical methods. Again, these optical methods are subdivided into atomic spectroscopy, molecular fluorescence and phosphorescence spectroscopy, nephelometry and turbidimetry. Among that, in this module, we are going to discussing the atomic spectroscopy. Content of this topic are introduction of atomic spectroscopy, types of atomic spectroscopy, principle of flame emission spectroscopy, preparation of sample solution, instrumentation of flame photometry, applications of emission spectroscopy. Now let us see what is meant by atomic spectroscopy. Atomic spectroscopy is the study of electromagnetic radiation absorbed and emitted by atoms. There are two types of atomic spectroscopy, that is atomic emission spectroscopy and atomic absorption spectroscopy. Now let us first see atomic emission spectroscopy. When an element is introduced into a flame, few of its atoms absorb thermal energy from the flame and get excited. The excitation is due to the transition of one of the electrons of the atoms from the ground energy level to a higher energy level. The energy required for this transition is provided by high temperature flame, an electric arc or spark. The lifetime of the excited electron is of very short period, hence this excited electron is quickly followed by the emission of radiation due to return of the electron to the lower energy level. These radiations emitted generally lie in the visible region of the spectrum. Each of the alkali and alkaline earth metals has a specific wavelength. The emitted radiation does not always have a single frequency. The excited electron may return to its original energy level in one step or in many steps. Hence, the de-excitation of the electron may be accompanied by the emission of radiation of several frequencies. These emitted frequencies produce distinct lines when observed in a spectrometer. These lines constitute the atomic emission spectrum of the element under study. For example, when the electron in sodium gets de-excited, it emits yellow light. There are again certain alkali and earth metals which can give color to the flame which they impart. That is, from the flame of the color of the flame we can identify which element is present. Sodium gives yellow color to the flame, potassium gives violet color, barium gives lime green color, calcium gives orange color, while lithium gives red color and strontium gives crimson red color to the flame. The atomic emission spectrum consists of bright lines against a dark background. Atomic absorption spectroscopy. Now let us see what is meant by atomic absorption spectroscopy. When a beam of radiation is passed through a flame containing atoms of an element in the ground state, the atoms absorb their characteristic wavelength. For example, sodium atoms will absorb radiation of wavelength 589 nanometer and 589.6 nanometer, The beam emerging from the flame is analyzed in a spectrometer, an absorption spectrum consisting of dark lines against a bright background is observed. These dark lines correspond to the absorption of characteristic radiation by the atoms of the element. For example, sodium absorption spectrum consists of two dark lines, that is at 589 nanometer and 589.6 nanometer against a white background. These lines are due to the absorption of light for the electrons to undergo transition from 3s to 3p orbital, that is from the ground state to the lowest excited level. Now let us see in detail flame emission spectroscopy. Flame emission spectroscopy is the study of emission of radiation of the element when their salt solutions are spread into the flame. The measurement of intensity of emitted radiation permits the quantitative estimation of the element, and determination of the wavelength of the emitted radiation help us to identify the element. Flame emission spectroscopy is also called as flame photometry. Now let us see the principle of flame emission spectroscopy. A metal salt solution is introduced into a flame. The following event takes place in rapid succession. The first step takes place is the evaporation. The solvent evaporates, leaving behind tiny solid particles of the salt. Then second step takes place, vaporization and atomization. The solid particles vaporize into gaseous molecules, which are then converted into gaseous atoms. For example, Mx is the solid salt which is getting converted into Mx, that is gaseous molecules of that metal salt. Then it is getting converted to gaseous atoms of that metal. Now the third step is the excitation. Some of the gaseous metal atoms in the ground state absorb thermal energy from the flame and are excited. The fraction of the metal atoms which are excited is given by Boltzmann distribution equation. According to that equation, m star upon m0, that is equal to A into e raised to minus delta E upon kt. m0 is the number of metal atoms in the ground state, m star is the number of metal atoms in the excited state, k is the Boltzmann constant, that is equal to r upon n, where r is the gas constant and n is the Avogadro's number. T is the absolute temperature, A is characteristic constant for the element under study, and delta E, that is nothing but that is equal to energy of electron in the higher excited state minus energy of electron in the ground state, that is equal to h nu. The fraction m star upon m0 that depends on the temperature, hence a high flame temperature is necessary for obtaining a large number of excited atoms. For example, an acetylene oxygen flame gives a flame temperature of 3000 degrees Celsius. Then fourth step takes place is the emission of radiation. The excited atoms are unstable and short-lived. They emit visible light, sometimes UV light, and return to the ground state. For example, m star metal atoms in the gaseous state, they go to the ground state, while going they emit the radiations having the energy h nu. The energy emitted by the radiation is given by the equation delta E is equal to E excited minus E ground state, that is equal to h nu, that is equal to hc upon lambda. The intensity of emitted radiation is directly proportional to the excited population atoms. Now let us see the sequence of events going to taking place while analyzing the sample in flame photometry. First, the sample is spread into the flame, then evaporation takes place. After that evaporation, the sample solution is converted into solid particles of that salt Mx. Then the solid particles of the salt They undergo vaporization and getting converted into gaseous molecules of that salt. Then these gaseous molecules of this metal salt undergo atomization and getting converted into gaseous atoms of that metal. Then these metal atoms in the ground state, they absorb thermal energy from the flame and go to the excited state. This excited state of the metal atom, that is of very short freight and it is unstable, therefore it returns to the ground state. While returning to the ground state, it emits the radiations having the energy H nu. Now the next part of this topic, that is preparation of the sample solution, then instrumentation of the flame photometry, then applications of flame photometry, we will see in the next video. Thank you.